So my name is Manish Kaushik. I am a student of IIIT Nagpur, CSC Section A, BTech branch, CSC branch. So this is my project, which is under the guidance of respected Dr. Nelson sir. So this is the project of my subject MI, that is microprocessor and interfaces. This project is given to us by Dr. Nelson sir. So this is our project that naming adaptive cruise control. So adaptive cruise control is basically a system or device that is used in cars to to ensure safety of the driver, so that there is no accident between the cars, which work on the basis that it uses camera and check the distance between both the cars, that will accelerate or deaccelerate the car, so that there is no happening between the both the cars. So it is basically for the safety of passengers and minimize the accidents and on the roads. So this is introduction smart driving with we'll use 8085 microprocessor in this. So definition: adaptive cruise control is an advanced driving feature that automatically adjusts vehicle speed to maintain a safe distance from the car in front, enhancing both safety and comfort. As I told you earlier, this is adaptive cruise control, advanced driving feature that automatically adjusts vehicle speed, that it will accelerate, deaccelerate, depends on the distance between the car in the front or back, enhancing both safety and comfort. So, as I've told you earlier, evolution of cruise control (ACC), that is adaptive cruise control, builds upon traditional cruise control using sensors to respond dynamically to the traffic conditions rather than maintaining a constant speed. So, if a driver is driving and let us suppose he slept, then the car will be driving at the constant speed. So there can be any happening between both the cars. So in the traffic, we use this adaptive cruise control. So the sensors used in ACC respond dynamically to the traffic conditions, that will accelerate or deaccelerate the speed, and this will be the best way of safety. Now, how ACC works? ACC employs radar or cameras to monitor the road and surrounding traffic, automatically adjusting speed to keep a preset distance from a vehicle speed. So, as I told you, they use radar or cameras to monitor the road and surroundings, means the another vehicle is at how much distance, so that it can minimize the speed. Now, fourth is safety and convenience benefits. ACC enhances safety by reducing collision risk. So that is basically accident and means you understand, and offers driver convenience by automating speed adjustments. I've told you that it will accelerate or deaccelerate the car, especially in stop and go traffic. So now next is Insurance Institute of Highway Safety. Now, memory allocation. At 1000, we'll allocate the current speed of the car. In 1001, we'll allocate set speed. 1002, target speed. That target vehicle speed means how much speed it require. at 1003, we'll store distance from the target vehicle. Now, next is decisions. Now, decision making will be required, as you know that if distance is less, or distance is equal to at what distance is moving, maintain constant speed. If less, then reduce the speed. If more, then increase the speed. So now, if distance is 5 meter, maintain constant speed. If distance is less than 5 meter, if current speed is greater than target speed, then brake level 2, means more brakes will be applied with more force. If current speed is less than target speed, then brake level 1, means current speed greater than target speed, then brake will be applied. Current speed less, then brake one level 1 will be applied. If distance lies between 5 and 10 meter, if current speed is greater than target speed, then brake level 1. If current speed is less than target speed, then acceleration level 1. You know the meaning of acceleration and brake level. Now, if distance is greater than 10 meter, then current speed is greater than set speed, then brake level 1. If current speed is less than set speed, acceleration level 2. If current speed is equals to set speed, acceleration level 0. We don't require any acceleration. It is moving at a constant speed, we let it move. Continuous loop for real-time decision making based on updated data. Okay. Now this is the loop in which it is explained clearly. Start, load BCDE pair with the respective data. Then there are two arrows, means the data will come from these. Call acceleration means it will go in that CMP composed with 4.5 meter. If distance is 5 meter, then call acceleration. And if distance is less than 5 meter, if distance is less than 5 meter, if current speed is less than the that we have written in the last page, we have explained it with a graph. Call break 2, if no, then call break 1. Now general purpose registers, mean those general purpose registers present in 8085 will be used to store. B register will be used to store current speed. C will be used to store set speed. D will be used to store target speed. And E distance. Now here, if distance is 10 meter, less than 10 meter, as we told you earlier, no. Then CPSD, the current speed greater than, if current speed greater than set speed, then if yes, then there. If no, then we'll come to this down condition. So in the same way, we'll move to the next page. Wait, let me a moment. Now this is the code. This is the code LXIH 1000. First we'll initialize the variable at 1000 position. Then we'll move B to the M. Then INXH. Similarly, it will be a loop. Then this will be for ACC 0. Then ACC 1, ACC 2. Then break 1. Code for adaptive. Then we'll go to break 1, break 2. It is this code for speed 1. Now here is break 2, speed 1, D check, speed target, and speed set. Yeah. This is the code of each and everything we are using here. Now here comes short briefing of the code. The code appears to be the assembly level program for an 8085 microprocessor. As we know, we are using microprocessor 8085. The code will be will be assembly language program for 8085. Implementing adaptive cruise control logic. Okay. The program continuously reads value from the consecutive memory location, that we means in which memory we are storing. It will read from the specific memory location assumed to represent current speed, set speed, target speed, and distance between vehicles, and enters a loop. Within the loop, it checks the distance and executes different branches based on specific conditions. Loop loop के मतलब inside the loop it checks the distance, means as we told you, if distance is less, then it will decrease the speed. If distance is more, it will accelerate but a little bit, and executes different branches based on the specific conditions. If the distance is 5, it maintains speed. Less than 5, it compares the current speed with the target speed, adjusting the speed accordingly through conditional jumps for acceleration and braking. Okay. Now, the loop continues to iterate, updating the memory location 1000 with the updated speed after each decision. So means the loop will iterate from starting from the 1000 position, and with the adjust speed matlab means after each decision it will adjust the speed with the current memory location. The program effectively uses conditional jumps and arithmetic instruction to dynamically adapt the vehicle speed based on the varying distances. This is the logic from the fourth page. We told you, if the speed is less, then it will decrease, and distance is less. So we come now based on varying distance and target speed, reflecting the decision making logic of an adaptive cruise control on the 8085 microprocessor. Now here, limitations and problems we faced. First is precision and range. The 8085 microprocessor have may have limitations in terms of precision and range. This could affect the accuracy of speed adjustments, especially when dealing with floating point arithmetic or large numerical values. This means we'll face problem in precision and range. If the range is very high, then we'll face problem with accuracy there. So this is the one of the limitations of the ACC. Now, sensor integration. Adaptive cruise control systems typically rely on sensors, that is radar or lidar, to accurately measure distances between vehicles. So the 8085 lacks built-in features for sensor integration. The 8085 microprocessor lacks in built-in features for sensor integration, potentially leading to challenges in the real-world distance measurement. So this is also the limitation for 8085 microprocessor ACC. Real-time clock. Effective adaptive cruise control requires precise timing for decision making. The 8085 might lack a dedicated real-time clock, making it challenging to synchronize actions with real-time events. As we told in first point, precision and range is the limitation of the 8085 microprocessor. So in the real-time clock, it will be the one of the major problems. Note, the 8085 microprocessor limitations impede rapid updates of speed and distance values in the adaptive cruise control. So these limitations impede rapid updates of speed and distance in the adaptive cruise control. Due to hardware constraints, the project may experience delays in responding to the real-time driving conditions, affecting the system's adaptability in fast-paced scenarios. If the car is running very fast and immediately the front one applies brake, so it will have no time to means it will have no times to decrease the speed or deaccelerate. So they can there can be any happening. So this is the main limitation. So thank you. This is the project by me, Manish Kaushik, and Sivraj Balikar, Manish Soni, and Himanshu Soni. Thank you.